Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This is question 3741, minimum distance between three equal elements 2. So relatively recent question. I think it just came out a couple hours ago in the weekly contest. I did not participate in it, but either way, I was able to do it completely on my own here. So again, let's go over it. So you're given an integer array nums, and what they're asking you to do is find a tuple of three distinct indices if they equal, all the values are equal in the triplet. That's basically what they're asking you to do, is find a triplet, and then you want to minimize the absolute differences of the indices with equal values. So if we want to minimize something, you know that means we're trying to start with infinity because anything has to be smaller than infinity and then return it at the end. Okay, cool. So otherwise, let's just go ahead and come up with a brute force solution first. So this is the naive solution n cubed, right? So triple loop. So starting I, J, K, going right, I, J, K, going right until you get to the end. And so if nums of I is equal to nums of J is equal to nums of K, then let's just call this the current distance, which is absolute I minus J plus absolute J minus K plus absolute K minus I. And then we want to minimize this with, current distance. And then at the end, we can just return answer, right? So, okay. And at the end, if there's no valid answer, if it stays as it was in the beginning, then we can just return the dummy -1 value, as it says right there. Okay. So you can see the runtime is 1094 milliseconds. That right there should tell you that it's going to be too slow. So let me show you the approach that I came up with to optimize this. So let's let this time out first. Okay, time limit exceeded. So the way I thought about this and the way I came up with the solution was to first, this is the same, right? So if we want all the same values, why don't we first track all the indices at the current value? So use the value as the key in the dictionary and use the indices as the value. So if we have a key with 1, we're going to have 0, 2, 3, because that's the location of where 1 appears, right? Okay, cool. So we're going to do this for all the values. And then I want you to notice something in that if we want to minimize, we want the closest three indices with the same value together. What that means is these are already sorted. Why? Because if we're scanning through the array, so 1, 2, 1, 1, 3, if we're scanning through the array with 0, 1, 2, 3, 4, if we're doing a standard for loop from left to right, these indices, as we encounter them, are already going to be in strictly increasing order. So what that means is these are already sorted, which means that if we just do a sliding window of size 3, that means we're going to get the closest 3 because they're sorted in order. The very next one is going to be the one that's closest to it in order, right? So yeah, so that's exactly the insight that I came up with and my intuition. So yeah, let's code it up. So given this model, let's create a default dictive type list. So for I, n, and enumerate nums. So d of n dot append I. Cool. So adding this, and then now for each key, let's call this dk, right? So again, let's use a sliding window of size 3 because we want triplets, right? And triplets with the closest value, they're already sorted. So we can just go through each 3, and instead of O of n cubed, this algorithm is going to be O of n squared, right? So let's call this 1, 2, 3 is going to be now I plus 1, now I plus 2. So if we're starting, let's say this was 1, and 0, 2, 4, 5, 7, just making up random numbers. We're going to say 1, 2, 3, 1, 2, 3, 1, 2, 3 till we get to the end, and then we're just going to compare these values because absolute value minimizing the difference is just going to be 4 minus 5 is going to be 1, is the same as 5 minus 4, right? So answer is minimum of answer current distance. This time the current distance is just going to be absolute of 1 minus 2 plus absolute of 2 minus 3. So same thing here, because these values are already the indices, right? Plus absolute 1 or 3 minus 1. And then at the end, same thing, we can just return answer. But again, we have to make sure if answer stays the same, then return -1. Okay, cool. So let's run this. Okay, submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So yeah, this is an n-squared algorithm, and yeah, it works because the keys of the dictionary are O of 1, so this is actually a very efficient scan, and then this is n by itself, right? So better than n cubed, enough to pass all the test cases. And even it says 100% runtime in memory, which I don't really get very often with the solutions that I managed to come up with by myself. So, yep, that's it for this video. Thank you for watching.